All right, so we have made it to Unit 7, Lesson 1. And we are going to talk about angles of polygons. So we are shifting a little bit from triangles to extending to properties of shapes that have more than 3 sides, right? So this whole concept of angles of polygons stems from triangles. The first thing to remember is that a triangle, interior angles, the sum for a triangle is 180 degrees, because that's what all of this is based off of. So the sum of the interior angles of any shape with more than 3 sides is determined by how many triangles we can draw, basically. So I'm going to try and kind of derive this formula, okay, from the shape you're given here. So look at this shape on the right. It has 6 sides, okay? And I'm going to pick one vertex, the vertex 1. And I'm going to draw diagonals, meaning a segment that doesn't connect and create a side, essentially. So connecting 2 vertices that aren't right next to each other. So I'm going to use 1, and I'm going to connect it to every other vertex except for 2 and 6. So I'm going to connect 1 to 3. I'm going to connect 1 to 4. And I'm going to connect 1 to 5. And what that creates is, it creates 1, 2, 3, 4 triangles, okay? 4 triangles. And if we remember, each triangle has 180 degrees, so 4 times 180, okay? 4 times 180 is 720. So the interior angle sum of this 6-sided shape is 720, okay? So with this formula, the general formula is to find the interior angle sum, you take number of sides minus 2 times 180, and that equals, times 180, and that equals your interior angle sum. Because if you look at this, 6 sides, 4 triangles, 8 sides, 6 triangles, 5 sides, 3 triangles. So the number of sides minus 2 times 180 is your sum. So we're going to use that formula in example 1. In example 1, we look at the shape. The shape has 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay, so our formula is going to be 8 minus 2 times 180, or 6 times 180, which, when I simplify that, 6 times 180 is 1080 degrees. That's how I find my sum. So multiplying the number of sides minus 2 times 180. So moving ahead, what if you're given the sum, okay, and you're trying to find the number of sides, okay? So in this example, it says the sum of the measures of the interior angles of a convex polygon is 900 degrees. And we're going to classify it by its number of sides. So we have to find the number of sides. So our formula was the number of sides minus 2 times 180 is the sum. So in this example, we know the sum, but we don't know the number of sides. So the way I'd set this up is I would do n minus 2 times 180 equals the sum, which we know is 900. So to solve this, I would divide by 180. N minus 2 equals 900 divided by 180, which is 5. And then using mental math to solve, n is 7. Okay, so the shape has 7 sides. If you want the actual name of a shape that has 7 sides, it's what's called a heptagon. Okay, heptagon. That's not as important, right? Memorizing the names. You should know quadrilateral is 4, pentagon is 5, hexagon is 6, octagon is 8. Past that, heptagon is 7. 9 sides is a nonagon. 10 sides is a decagon. But again, if you don't remember those, that's fine, but you're just classifying it by saying it has 7 sides. I'm fine with that. Okay, moving ahead. This is going to be a big one for the rest of this unit, is the one shape I want you to memorize, like we memorized triangles. The interior angles add to equal 180. For a quadrilateral, the sum of the interior angles is always for a four-sided shape, a quadrilateral, is always 360 degrees. So we're going to illustrate that in example 3. This is a quadrilateral. I know the sum of these 4 angles is 360 degrees. So I'm going to set up and solve an equation to find that missing angle. So I'm going to write out the sum, x plus 108 plus 121 plus 59. That sum is 360 degrees. So I'm going to combine all the like terms on that left-hand side before I solve. X plus 288 equals 360. And then x equals 360 minus 288, 72 degrees. That missing angle is 72 degrees. So I think it's helpful to set up and solve an equation in these situations because you're not always just going to have x. You're going to have maybe like 3x, 4x, 5x. It might be something a little bit more complex. So I think it's good to get into the habit of setting up and solving an equation. So that being said, I'd like you to take a minute to try the guided practice. It's literally example 1, example 2, and example 3, just with different numbers. So try those on your own. Check your answers with me in a minute, once you're ready. Okay, so guided practice. Number 1, I just substituted 11 into our formula. 11 minus 2 is 9. 9 times 180, 1,620. For number 2, reversing our formula, the sum is 1440. I solved for n, the number of sides. I got 10. That shape is a decagon. Number 3, I set up my equation as a sum of 4 angles. Knowing it's a quadrilateral, I knew that sum was 360. Okay, and then I solved that for x. I got x was 22.5, but that's not enough because I asked for the measure of all of the angles. So I did, I had that, and then I did 3 times 22.5, 5 times 22.5, and 7 times 22.5 to find the other 3 angles. So just applying some of those properties. Moving ahead, quick review of equilateral, equiangular, and regular. Equilateral shapes, or polygons, all sides are congruent. Equiangular shapes, all angles are congruent. A regular shape is both equiangular and equilateral at the same time. So, in example 4, it says a home plate is shown, it's a pentagon. Is it regular? So when we look at this, yes, every angle is marked, but these angles, angle A is 90 degrees, angle B is 90 degrees, angle D is 90 degrees. E and C are not necessarily 90 degrees. E is congruent to C, but we have no indication that E and C are congruent to the other angles. So this polygon is not even equiangular as far as we know. So we would say, no, the polygon is not equiangular. Okay? It is not equiangular, so it can't be regular. And a quick explanation of that, looking at this, thinking about our formula, it's a 5-sided shape. So if I did 5 minus 2 is 3 times 180, that would mean this sum would be 540, okay? And if I wanted to figure out what E and C were, that kind of leads into my next question, but the sum is 540. So to find these missing 2 angles, let's just label them both as x since they're the same as each other. I would do 540 minus 9. Actually, let's I'm going to stop for a second there and slow down. The sum is 540. We don't know what E and C are, but we know what the other three angles are. So let's go back to what we did before and set up an equation. How about that? So I would do x plus 90 plus 90 plus 90 equals 540, which would really be 2x plus 270 equals 540. And if I solve that, that would be 2x equals 270. X is 135. So I'm going to do this in a different color so it's not so messy. Measure of angle C and measure of angle E are both 135 degrees. Sorry if that's hard to read. And that kind of proves it's not equiangular, so it's not regular. So that kind of goes further to prove why it's not equiangular. Okay. So there's one more property or one more theorem to talk about, and it's talking about exterior angles. And the definition of an exterior angle is if I took a side and I extended it, and I took another side and I extended it, and I took another side and I extended it, I would be creating exterior angles, right? So every shape, okay, and I don't know why I put a 2 there, but that 2 you can ignore. The sum of the measures of the exterior angles of any sides, okay, a polygon of any side measure, or any side measure, any number of sides is always 360. A 4-sided shape, a 20-sided shape. The exterior angle sum is 360. So, in example 5, same as before, it's knowing this is the sum, regardless of the number of sides, is 360. So 2x plus x plus 89 plus 67 is 360. So that sum for exterior angles is always 360. So 2x plus x is 3x, 89 plus 67 is 156, set equal to 360. Subtract 156 from both sides. I get 204. 204 divided by 3. X is 68. Okay, so that missing angle here is 68. The other one is 136. 68 times 2 is 136. I know I only asked for that value of x, but I just wanted to show that's how we'd find those other angles if we were asking for it, right? So, last example, example 6 here, says we're going to find the angle measures in a regular polygon. So it says find the measure of each interior angle of a regular dodecagon. So right here I'll give you a dodecagon has 12 sides, and it would help to know the interior angle sum of a dodecagon. So the interior angle sum of a dodecagon is 12 minus 10 times 180, or sorry, not 12 times 10, my bad, 12 times 2 times 180, and then it will be 10 times 180. Okay, sorry about that. That would be 1800. Okay, so the sum is 1800. Now, for me to know the measure of each angle, it's understanding in a regular dodecagon, all 12 angles are the same measure. So I'm essentially dividing the interior angle sum equally among 12 angles, meaning each angle would be 150 degrees. 150. See if I can write that so it's legible. 150 degrees, right? So knowing how to find the sum, we can find each measure of a regular shape by dividing by the number of sides or the number of angles, because the number of sides is always equal to the number of angles. In part B, find the measure of each exterior angle of a regular dodecagon. So this is just remembering exterior angles. We don't need a fancy formula. We just need to know the sum of the exterior angles of any shape is 360. And if it's a regular shape, each of those exterior angles are congruent to each other, meaning I'm dividing this 360 equally between 12 angles. That means each exterior angle is 30 degrees. 360 divided by 12 is 30. And it kind of should make sense, and I'm not going to draw a dodecagon, but I'll draw just some sort of quadrilateral. And if I draw my, my exterior angles, okay, however I want to draw them, okay, if you look at it, each exterior angle plus each interior angle creates a line, which means each of these is 180. So if you think about it, for A and B, they kind of connect. 150 plus 30 creates that 180. So that's how we can kind of compare. But it's just remembering our formula for interior angle sum and the general exterior angles are always, the sum is always 360. So it looks like got through those, ready for some practice. Make sure you go through the practice before you attempt the checkpoint.